Today, we're diving into a sophisticated cyber threat known as the process hollowing technique, a method attackers use to hide malicious code. This technique involves replacing the legitimate code of a running process with malicious code, making it appear as a harmless, trusted application to the operating system. Attackers often target common system processes like coast.exe to execute their payload, blending in with normal system activity. The first step in this technique is to create a new, legitimate process, such as coast.exe, but crucially, it's launched in a suspended state. This suspended state prevents the legitimate code from executing, providing a window for the attacker to manipulate the process's memory. Next, the attacker unmaps or hollows out the memory section where the legitimate process's original code resides. This creates a blank canvas within the process's address space, ready to be filled with the malicious payload. Following this, new memory is allocated within the hollowed-out process, specifically designed to house the attacker's malicious code. The malicious payload is then written into this newly allocated memory, effectively replacing the original, legitimate program. This payload can be anything from ransomware to spyware, designed to achieve the attacker's objectives without detection. A critical step is to set the process's entry point to the beginning of the malicious code. This ensures that when the process resumes, it will execute the attacker's code instead of the original legitimate program. Finally, the suspended thread of the process is resumed, allowing the now malicious process to run as if it were the original, legitimate application. Because the process name and other attributes remain unchanged, it's incredibly difficult for traditional security tools to detect this compromise. The operating system sees a legitimate process running, unaware that its internal code has been completely swapped out. This stealth allows attackers to maintain persistence, evade detection, and execute arbitrary code with the privileges of the legitimate process. Defending against process hollowing requires advanced endpoint detection and response solutions that can analyze process behavior and memory integrity. These tools look for anomalies like a process writing to its own executable memory or unusual memory allocations. Regular patching and keeping software up to date also reduce the attack surface, preventing initial compromise vectors. Understanding techniques like process hollowing is crucial for cybersecurity professionals to build more resilient defense strategies. By recognizing how attackers operate, we can better anticipate and mitigate these sophisticated threats. Stay vigilant, stay informed, and continue to strengthen your cybersecurity posture against evolving attack methods.